Welcome to the Ford New Model Training Program on the 7.3-liter DI Turbo Diesel. This video, along with the accompanying workbook, is designed to provide you with the skills and knowledge necessary to describe and diagnose drivability concerns on the 7.3-liter DI Turbo. The 1994 7.3-liter DI turbocharged diesel engine will be available in F-Series vehicles over 8,500 pounds GVWR, equipped with a ZF manual transmission. The in-head fuel system is entirely new and uses an EEC5 system with a 104-pin connector and 115-volt injectors. The emission control system uses a catalytic converter to lower oxides of nitrogen emissions, and the all-new electronically controlled glow plug system provides excellent cold weather starting capability. Lesson 1. Fuel Supply System. After viewing this lesson and reviewing the accompanying workbook, you should be able to describe the purpose of the fuel supply system and identify, locate, and describe the operation of related components. The new fuel supply system includes the following components: the tandem mechanical lift pump, fuel filter, heater, and water separator assembly, fuel passages, and the fuel pressure regulator block. Fuel is drawn from a fuel tank by the low pressure stage of the tandem mechanical lift pump. Low-pressure fuel is sent to the fuel filter, heater, and water separator assembly. Filtered fuel is routed to the high-pressure stage of the tandem mechanical lift pump. High-pressure fuel is supplied to the fuel passages in the cylinder heads. Excess fuel from the fuel passages is routed to the fuel pressure regulator block for either recirculation through the system or return to a fuel tank. The filter is a cartridge-type element attached to a threaded filter assembly cover. The filter element must be locked to the assembly cover to seat properly in the assembly. It is important that the bevel-cut gasket be oriented properly or the assembly will leak. The fuel enters the fuel filter assembly and passes through the filter element to a standpipe in the center of the filter assembly. Important note: the standpipe in the center of the filter housing contains a shutoff valve. The valve is open only when the fuel filter element is properly mounted in the filter housing. The engine will not run without the fuel filter element in place. Return fuel passes through a strainer cup attached to the regulator block. Important note: the strainer cup contains a nylon strainer that must be kept in place to prevent plugging of the limiting orifice. The fuel returned to the tank passes through a 20,000-inch orifice, which limits the flow of hot fuel to the tank. Air in the system is also vented back to the fuel tank through the 20,000-inch orifice. If the orifice becomes plugged, the fuel system will not vent properly, and engine performance may be adversely affected. A fuel pressure test port is located on the pressure regulator block. A plastic cap protects the port. Fuel pressure at the regulator block should be 40 to 60 psi. Fuel pressure less than 15 psi may cause the engine to misfire. This could be misdiagnosed as an injector or injection control system problem. The fuel pressure at the regulator block should be verified in accordance with the proper diagnostic procedures before checking the injector and injection control system. This is the end of Lesson 1. Please stop the tape and return to your workbook. Do not rewind the tape. Lesson 2. Injection Control Pressure System. After viewing this lesson and reviewing the accompanying workbook, you should be able to describe the purpose of the injection control pressure system and identify, locate, and describe the operation of related components. and describe the purpose of the fuel injector assembly, and identify and describe the operation of related components. The injection control pressure system includes the following components: the engine oil pump, G-rotor type, oil reservoir, high-pressure oil pump, high-pressure hoses, high-pressure oil rails, hydraulically actuated electronically controlled unit injectors or HUI, injection control pressure or ICP sensor, and the injection control pressure regulator or IPR. The engine oil pump feeds the oil reservoir, which supplies the high-pressure oil pump. The pressure of the oil from the high-pressure pump is limited by the injection control pressure regulator or IPR. The high-pressure pump supplies oil to the oil rails in the cylinder heads through special high-pressure hoses. The injection control pressure or ICP sensor provides oil rail pressure information to the powertrain control module or PCM. The oil rails deliver high-pressure oil to the hydraulically actuated electronically controlled unit injectors or HUI. Prior to the removal of the oil reservoir or the high-pressure pump, the oil in the reservoir should be removed to avoid spilling. This can be accomplished with a suction gun or vacuum pump with a large reservoir, greater than 1 quart. Insert the tube into the port on the top right of the reservoir and extract the oil. The steel braided hoses between the high-pressure pump and the oil rails in the cylinder head are made of a special Teflon material to meet burst strength requirements. Caution: it is very important to use the proper replacement hoses. Replacement hoses must be certified Ford replacement parts only. The convoluted plastic covers over the hoses are there to prevent chafing. The protective covers must be in place. Injector fuel and oil are separated and sealed by O-rings. The uppermost O-ring seal has a steel backup ring and a backup O-ring. The middle O-ring seal also has a backup O-ring. The uppermost and middle O-rings seal the intersection of the injector and the oil rail in the cylinder head. The third O-ring seals the intersection of the injector and the fuel passage. The copper gasket at the bottom of the injector seals the injector and the combustion chamber. It's important to remember that injector O-rings should be installed from the largest O-ring to the smallest. Always use new O-ring seals when installing an injector, and carefully follow the O-ring assembly instructions included in the package with the service O-ring kit. Some important points to keep in mind when servicing injectors. Remember that the injector oil spill spouts must be removed prior to injector removal. Also, the spill spout is bolted to the hold down, and the hold down is pried on for injector removal. Note: the injector is assembled at the factory with computer-controlled fixtures. The injector is not field repairable. The injector cannot be hand-assembled and function correctly. Injector warranty may be denied if there's evidence of tampering. Also note: use only methods and tools described in the service manual for injector removal and installation. Never strike the injector solenoid during installation, as this can cause the internal poppet valve to shift or break the plastic solenoid case. High-pressure oil in the rails is used to actuate the injectors. There are 3 stages of injection: the fill cycle, injection, and end of injection. During pre-injection, all internal components have returned to their non-actuated positions. The solenoid is not energized, and the poppet valve is blocking high-pressure oil from entering the injector. The intensifier piston is at the top of its stroke, and the area below the plunger is full of fuel. Fuel pressure under the plunger is equal to fuel passage pressure, approximately 40 to 60 psi. When the PCM determines that the injector should be fired, the solenoid is fully energized, which almost instantly creates a strong magnetic pull on the armature connected to the poppet valve. The magnetic pull on the armature overcomes the spring pressure holding the poppet valve closed, and the poppet valve opens. When the poppet valve opens, high-pressure oil flows into the injector on top of the intensifier piston. Pressure on top of the piston forces the plunger down, increasing the pressure of the fuel under the plunger. When fuel pressure reaches a valve opening pressure or VOP of about 2,700 psi, the nozzle valve lifts off its seat and injection begins. As long as the solenoid is energized, the poppet remains open and pressurized oil continues to flow into the injector, pushing down the piston and plunger. Injection pressure ranges from 3,000 to 21,000 psi, depending on engine requirements. Injection continues until the solenoid is de-energized and the poppet valve closes, or until the intensifier piston reaches the bottom of its bore. When the solenoid is de-energized, the magnetic field of the solenoid collapses and spring pressure seats the poppet valve. The flow of oil into the injector stops and oil used to actuate the injector is discharged through the drain hole to the spill spout. The spill spout directs the oil into the camshaft area of the crankcase. This allows the oil to return to sump. When oil pressure above the intensifier piston is released, spring pressure moves the piston upward. The remaining oil above the piston is pushed out of the injector through the drain hole. Fuel pressure from the fuel passage unseats the fuel fill check ball, and fuel flows into the injector. The injection cycle is complete and is ready to begin again. This is the end of Lesson 2. Please stop the tape and return to your workbook. Do not rewind the tape. Lesson 3, Powertrain Controls. After viewing this lesson and reviewing the accompanying workbook, you should be able to describe the purpose of the powertrain control system for base engine function, and identify, locate, and describe the operation of related input and output components, as well as describe the function of the powertrain control system as it relates to the vehicle speed control function, and identify, locate, and describe the operation of related input and control devices. The major components that make up the powertrain control system are the Powertrain Control Module, or PCM, the Injector Drive Module, or IDM, and the fuel injectors. The PCM receives engine and vehicle condition information from inputs and controls engine and vehicle performance with outputs. The PCM controls engine performance using information received from the following inputs: the accelerator pedal or AP sensor, the idle validation switch or IVS, the intake air temperature or IAT sensor, the exhaust back pressure or EBP sensor, the camshaft position or CMP sensor, the injection control pressure or ICP sensor, electronic feedback or EF or IDM feedback, the engine oil temperature or EOT sensor, manifold absolute pressure or MAP sensor, barometric pressure or BARO sensor, and the parking brake applied or PBA switch. The PCM controls the speed control system using the following vehicle inputs: the brake on-off or BOO switch, the brake pressure applied or BPA switch, the clutch pedal position CPP switch, speed control command switches or SCCS, and the vehicle speed signal. The PCM controls engine and vehicle performance and also provides operating condition information through the following engine and vehicle outputs: the cylinder identification or CID, IDM enable or IDM-EN, fuel delivery control signal or FCCS, exhaust back pressure regulator or EPR, injection control pressure regulator or IPR, self-test output or STO, tachometer output or TAC, glow plug or GP relay control, glow plug or GP light signal, and the check engine light. The wiring to the injectors is routed through the valve cover gasket for increased durability. The reusable gasket is reinforced to prevent damage from over-tightening of fasteners. The 5-pin connectors supply glow plug power as well as voltage and ground for the injectors. Caution: do not perform any voltage checks with the engine running. 115 volts DC is available on injector circuits. Remember, do not pierce the red striped harness and follow shop manual test procedures. The exhaust back pressure is controlled by the PCM to provide more heat to the coolant for cab heating when ambient air temperature is below 45 degrees Fahrenheit, 7 degrees centigrade, and oil engine temperature is below 167 degrees Fahrenheit, 75 degrees centigrade during low load, low speed operating conditions. At high load, high speed conditions, the back pressure system is disabled. The EBP regulator solenoid and EBP piston are contained in the turbocharger mounting pedestal. Oil regulated by the EBP solenoid actuates the piston, which operates the back pressure valve in the exhaust housing. The self-test output, STO, is used to transfer self-test codes to a self-test code reader, or star tester. Codes are transmitted from the PCM to the tester by pushing the STO pin. Also, the check engine light will be illuminated when it's grounded. An open circuit will result in an inoperative check engine light. A short to ground will cause the check engine light to always be illuminated. Also, an open or short circuit will result in an inability to transfer self-test codes to the star tester. The amber-colored check engine light illuminates to indicate when certain failure modes have been detected by the PCM or IDM. The light is located in the instrument cluster and is turned on every time a key-on reset occurs to verify proper bulb operation. The light illuminates when failure modes have been detected, which result in a change in power output available from the engine. This is the end of Lesson 3. Please stop the tape and return to your workbook. Do not rewind the tape. Lesson 4, Diagnostics. After viewing this lesson and reviewing the accompanying workbook, you should be able to describe the interrelationships between components and symptoms related to the fuel injection control pressure system, and perform diagnosis and testing of the system. Describe the interrelationships between components and symptoms related to vehicle speed control, and perform diagnosis and testing of the system. And describe the interrelationships between components and symptoms related to the powertrain control system, and perform diagnosis and testing of the system. The PCM is constantly monitoring all input and output devices to watch for malfunctions. In addition, a self-test routine can be initiated to help diagnose an engine performance symptom. The self-test can be run in two operating modes: key on engine off, KO-EO, and key on engine running, KO-ER. During the self-tests, diagnostic trouble codes are transmitted to a STAR, self-test automatic readout tester. The key on engine off self-test includes standard tests and special tests. The standard tests include the end-of-the-line test, which checks the PCM processing functions; the ROM Checksum, which checks the PCM read-only memory, ROM; and the output circuit check test, which checks each output device individually. The KO/EO special tests include the injector buzz test, which electrically checks the injectors individually. The output state test, which checks outputs by toggling between highest voltage output and ground each time the accelerator is pressed during the test. And the wiggle test, which checks wiring connections at the harness as the technician wiggles each of them. Two types of diagnostic trouble codes are transmitted to the star tester during KO/EO self-tests: hard faults and continuous memory faults. Hard faults are hardware failures identified by the KO/EO test. Continuous memory faults are failures detected by the PCM during engine operation, which are stored until being transmitted to the star tester during the KO/EO. The key-on engine running self-test consists of three tests: the switch test, which checks AP, SCCS, BOO, BPA, and CPP switches; the standard test, which checks ICP and EBP valves; and the cylinder contribution test, which checks each cylinder. Note, the KO/EO standard test and the KO/ER standard test are two completely different tests. Fault codes resulting from these tests are transmitted to the star tester during KO/ER testing. No continuous memory codes are transmitted during the KO/ER test. The procedures for both the KO/EO and KO/ER tests are included in the PCED manual. Be sure to follow all instructions carefully to ensure accurate test results. This is the end of Lesson 4. Please stop the tape and return to your workbook. Do not rewind the tape. The following will provide you with an overview of some of the engine service features that are unique to the 7.3-liter DI turbo. When checking the air induction system, be sure to inspect the air cleaner housing and filter for proper installation. Inspect the filter minder to assure intake restriction is below the red marking. Fuel filter removal. Drain the filter housing. Next, using a screwdriver or bar, remove the fuel filter cap. The fuel filter element will come out with the cap. Then remove and discard the bevel gasket. Press in on the fuel filter element locking tabs to separate the element from the cap. Fuel filter installation. Note, the engine will not run if the fuel filter is not correctly installed in the housing. First, apply a coating of clean diesel fuel to the new bevel gasket and install it onto the fuel filter housing gland. Now, install a new fuel filter element onto the cap. Place the new fuel filter element and the cap into the fuel filter housing. Allow fuel to soak into the fuel filter element. Then tighten the cap onto the fuel filter housing until the cap contacts the aluminum housing. High-pressure oil pump installation. Note, make sure the oil pump drive sprocket is fully seated before installing the bolt and washer, or the sprocket may not seat properly. The end of the high-pressure oil pump shaft should be flush with the front face of the oil pump drive sprocket. Red striped wiring harness. Please note the special warning labels located on both valve covers. Warning: the red striped harness carries 115 volts direct current. Severe electrical shock may be received. Caution: do not pierce the harness. HEUI injector. Caution: do not attempt to service the fuel injector. The fuel injector is serviced as an assembly. Fuel injector removal. The following special service tool is required: injector remover T94T 9000 AH1. Remove the valve cover. Disconnect the fuel injector electrical connector. Caution: failure to remove the oil rail drain plugs prior to removing the fuel injectors will allow oil to enter the combustion chamber and could result in hydrostatic lock and severe engine damage. Now, remove the internal oil rail drain plugs in the cylinder head to drain the cylinder head. Drain the fuel passages. Remove the retaining screw and oil deflector. The shoulder bolt on the inboard side of the fuel injector does not require removal. Remove the outboard fuel injector retaining bolt. Note: when servicing the fuel injector, it's important that all 3 injector O-rings and the injector tip copper washer are retrieved from the injector bore. Carefully remove the fuel injector using the injector remover. Place the fuel injector into an injector protective sleeve and set the fuel injector in the injector holding rack. Fuel injector installation. Install the fuel injector using the injector replacer T94T 9000 AH2. During cooling system service, remove the clutch fan assembly using the fan clutch nut wrench T83T 6312B and the fan clutch pulley holder T94T 6312AH. Caution: this is a right-hand thread. Remove it by turning the nut counterclockwise. These are the tools included in the mandatory equipment kit. These are the tools included in the Essential Special Service Tools kit. This video is intended to provide you with a basic understanding of 7.3-liter DI turbo diesel drivability concerns. Remember, procedures and specifications are subject to change without notice. Always consult the latest available information. Please rewind the tape and return to your workbook.